Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, in today's class we are going to cover, we are going to complete an entire chapter of physical quantities and measurements. So this is the first chapter in a class 7th ICSE. Of course, for other boards also, this is a very important only. So dear children, before going to get into the discussion, let us see the what is today's agenda. What we are going to discuss, what we are going to do in an entire class. So dear children, just look at on the board. So first we do the recap. So under recap, what we will do? Hey, did you remember? You also learned few concepts related to the physical quantities and measurements in the class 6. You may get on doubt, sir, class 6, it was like a past. Once upon a time, there was a class 6th, but we forgot the concept, sir. Don't worry. I'm here to recap. I'm here to recollect the complete information. Complete information means, again, don't get confused. I'm not going to teach you class 6th again. Okay, it's not that, but the important information, the important concepts related to the class 7th only, we'll try to discuss under recap. Once recap is done, we are going to get into the complete concepts of class 7th. So in a class 7th, physical quantities and measurements, mainly what are we going to cover? Yes, we are going to discuss about speed and its units. Next we discuss about area, its units. So under the area, dear children, we are going to discuss about the how to calculate the area of regular bodies and how to calculate the area of irregular bodies. Once we complete the area, dear children, we are going to discuss about the volume. What is a volume? Volume units and the volume of regular bodies, volume of irregular bodies. Okay, now. So once volume also done, last topic is the density. So what is the density? Density units and conversions, and we also will discuss how to find the density of regular bodies and irregular bodies. So dear children, so these are the what we can say complete concepts which we are going to discuss in today's class. And you may get one doubt actually, if you can see the sequence of our agenda, you may get confused. Sir, in textbook first I think they gave some volume, they gave, then area, density, some children, whatever it may be here in textbook, try to understand. So in a textbook, I feel that the sequence is missing. So my suggestion is that, yes, you learn in this sequence only. First learn about the speed, then area, then volume. Why am I asking you to learn volume after area? This area is a two-dimensional concept. Volume is a three-dimensional. Once you learn about the volume, then you have to learn about the density, because density we will discuss in terms of volume. That is our idea. Okay, fine. So without doing delay, let us try to do the recap for today's class. So children, under recap, first we are... Yeah, children, I forgot to ask you one thing. Are you all ready with the notebooks? It's very important. Come on. Let us take the notebooks. Be ready to note down the important points so that you should do the best in your exams, right? Okay? Yes, I think you all are ready with your notebooks. Okay? Chalo. Physical quantity. So, teacher, what is a physical quantity? Actually, before that, let us think about, I think, of course, we all will love our parents. Yes or no? Yes, of course, we all will love parents. Can you tell how much do we love? No, we cannot measure. Yes, we respect elders. Can you measure how much do you respect? No. We like many things. Can you measure how much do you like? No. So what I mean, these are the, emotions. Love, like, irritation, frustration, angry, hungry, like, dislike. Okay, so these things we can't measure. But if I ask you about your height, are you able to? Come on children. Yes, try to just comment your answer. What is your height? In a meters and centimeters. And what is your weight? Are you able to measure your weight? Come on. And are you able to measure the time, children? What is the right now time? What's the time now? Oh my God, in my clock it is almost, night, almost 1:30. Okay, fine. Okay, what is the time? I mean to say, why I'm asking to mention in a comment box, I want to know whether you are able to measure time or not. Hey, as I'm talking about height, weight, mass, time, can we measure all these things? Yes, we can measure. Children, can you measure the area of your room? We can measure. So I mean to say that, like a time, temperature, mass, weight, area, example, many are there. So these quantities can be measured. So the quantities which are measurable are called physical quantities. I repeat once again, what is the physical quantity? The quantity which is measurable are called physical quantities. Like we can measure the speed, physical speed is a physical quantity. We can measure the area is a physical quantity. We can measure the volume is a physical quantity. We can measure the density is a physical quantity. Clear? Fine. So children, physical quantities are of two types actually. Physical quantities are two types here. So here fundamental quantities, try to understand. Not mental quantities. No, it's not the mental quantities. Fundamental quantities. Next here is derived quantities. So children, derived quantities. Children here, of course, see, by keeping a class 6th only I am talking. When you go for higher classes, you learn in detail, but I am not going in detail, try to understand. Whatever is needed for a 7th class, that much only we are going to learn. So here, under fundamental quantities, actually, we have, children, try to understand mass, time, length, okay, and temperature, okay, amount of substance. What is that? Please note down. Amount of substance, electric current, intensity of light or luminous intensity, How many we got? 1, 2, 3, 4, 5, 6, 7. So 7 fundamental quantities you learn. But in a class 6th, we learnt about mass, time, length, temperature. So these 4 are important for us also. Remaining things not required. Okay, fine. So derived quantities means, yes, here is area, volume, speed, okay, density. Children, if you can notice, of course, these are the topics which we are going to learn in a class 7th. These are the topics which you had learned in a class 6th, which means what? In a class 6, you learnt about the fundamental quantities. Now in a class 7, we are going to learn about the derived quantities. Now let us recall once again, what are fundamental quantities? Children, the quantities which do not depend on any other quantities are called fundamental. These are the basic quantities. These are the independent quantities. These quantities do not depend on any other quantities. Means by using any other physical quantities, you cannot derive these quantities. Such a quantities only fundamental quantities. Then what are derived quantities, children? Yes, the quantities which are derived from the fundamental quantities. Derived from the fundamental quantities, which means what? Derived quantities will depend on the fundamental quantities. Just a small example I want to tell you. It may not be exactly, but it is apt for this. Right? For example, here let us say that's a parents, here children. Okay, so children will depend on the parents. I mean to say in general I am talking. Don't take out any special cases. Okay, now children will depend on parents. Means parents are independent, children are dependent. So like that, fundamental quantities are independent, derived quantities are dependent. Okay, now, so children, once again I repeat here, you in a class 6th, you had learnt about mass, time, length, temperature. These are the fundamental quantities. In a class 7th, I mean right now in today's class, we will be talking about the derived quantities. Before going to discuss about these derived quantities, let us recall about the units of these fundamental quantities. Children, if you can take the mass, for a mass, SI unit is kg, whereas CG's unit is grams. That's it. Okay, fine. Now if you can take a length, children, length, okay, so SI unit of length is meter. I'm writing the just symbols, whereas CG's unit is centimeter. And if you can see the time, so for a time in all systems, the unit is second only. The symbol is yes. Next here is a temperature. So children, for an SI unit of temperature is kelvins. Now look at here. Once again, let us see the relation, children. We know that 1 kg is equal to 1000 grams. It also can be written as 10 power 3 grams, or 1 gram is equal to 10 power minus 3 kg. Okay, whereas here 1 meter is equal to 100 centimeters. It can be written as 10 square centimeters, or 1 centimeter is equal to 10 power minus 2 meters. You may get a doubt, sir, how can you write? You are writing very fast, you are not explaining. Children, these things we had learned in class 6th. Just I am doing recapitulations. Recap it is. Already you had learned in a class 6th only. Okay, so these are the things which you learn. Okay, temperature. How can you measure temperature? By using a device called thermometer. So in a class 6, you had learned about the clinical thermometer and what we can say laboratory thermometer also. So these are the concepts. Okay, fine. So this is about physical quantity and the types of physical quantities, and these are the fundamental quantities. Especially in the class 6, you have learned about only mass, time, length, temperature. So about remaining these fundamental quantities you will be learning in a class 9th and a class 11th also. Class 9th and class 11th also. That's fine. And how can we express this physical quantity, children? Then how can we express? Are you able to see the board? Sorry, without asking you just erase. Yes, okay. So how can we express the physical quantity? For suppose someone will ask you to tell about your height. So we can tell height, some X person's height is. So height is equal to, we can say some 160 centimeters. Okay. So here height is physical quantity, 160 is numeric value, centimeter is unit. Centimeter is unit. So how can we express physical quantity, children? Any physical quantity can be expressed in terms of two parameters. Two parameters are needed to express the physical quantity. So physical quantity is equal, that is a numeric value into unit. So physical quantity can be expressed in terms of two parameters. Unit a number, unit a unit. Unit a number, unit is a unit. Okay, fine. So before going to just recall about the unit, let us talk about the measurement, children. What is measurement? Of course, this is chapter name also, right? Physical quantity we learn. Physical quantity and measurement. Now we should discuss about the measurement also. What is a measurement? Measurement is a comparison. Without comparison, we can't do anything. I mean, perfectly we can't do it. For children, for example, here one person is there. Person A. Is this person tall or short? Is this person tall or short? Come on, comment your answer. Is this person short or tall? Come on. Okay, comment your answer. Yes, look at here. I think we can't say tall or short. Now, if I say that, now here is a person B. Now you tell me, is this person A tall or short? Come on, tell me, children. Yes, when you can compare the person B, you can say that this fellow is a tall. That's great. Of course, wonderful. Now, if I ask you to tell about the person A is a tall or short now, of course, now if you can compare with the person C, he is a, what we can say, short. Hey, means person A can be tall, can be short. How it is possible? Same person can be short and can be tall. Yes, it is possible. It depends on the comparison with what you are doing comparison. So, children, indirectly we are trying to measure, as your comparison itself is a measurement. Means every measurement involves some what we can say comparison. So measurement is the comparison of an unknown quantity with a known quantity of same nature or same kind. This is a definition which you had learnt already in a class 6th. Still recap is going there, children. Try to understand. What is a measurement? Comparison of an unknown quantity with a known quantity of same nature. Unknown quantity means what? For example, you go to a shop to purchase some rice. This amount of rice you want to purchase. It is a unknown. For that, to measure that, we use some weights, right? 1 kg weight, 2 kg weight. This is a known quantity. You are measuring means what? You are comparing. For example, if you will ask you 10 kg rice. 10 kg rice means what that shoppers will do? He will give you 10 times when compared to this 1 kg. 1 kg, try to understand. So 10 kg rice is contained 1 kg 10 times. So that is what actually comparison. So children, what is the measurement? It is a process of comparison of an unknown quantity with a known quantity of same nature. Rather I can say known standard quantity. This is known standard quantity. This simply, this known standard quantity only we can call it as a unit. So now we will discuss, we will try to recap about the unit. So hope this measurement is clear. Children, we are not discussing in depth, I repeat, still we are discussing the few concepts which you had learned in a class 6 so that you do the best in class 7th. Okay, fine. So next, unit D, children. So what is this unit? Yes, unit is nothing but the known standard quantity. Standard quantity. Known standard quantity. So unit is a known standard quantity which is used to measure the unknown quantity of same nature is called unit actually. So standard means what? Very, very important. Standard itself, it should not change with the space and time. Yes, so how can we select a unit? The name itself will give you the children. For here few points will be there regarding the unit. These are very, very important. What the first point, very, very important. Unit means it must be accepted universally. So universally it must be accepted. Second point, unit should not change with the space and time. It's like a morning 1 kg, evening 1 kg. Should not differ, children. 1 kg weight should be like same only. And whether you measure in a Warangal, measure in Hyderabad, measure in Delhi, should be same. Should not change with even place also. And it should be well defined without any ambiguity also. And it should be of convenient in size. So these are the 4 important characteristics of the unit. Let us recall once again. What is the first one, teacher? Yes, so it should be universally accepted. It should not change with the space and time. It should be of convenient in size, and it should be well defined. It should be defined without any ambiguity, without any doubt. Okay, so this information is it's needed to understand now in a class 7 topics. So till now whatever we discussed, it's a recap which you had learnt in a class 6, children. Okay, now get ready. Children, as I am saying now, get ready means it doesn't mean that you may forget a previous topics, what we had discussed, what we just did a recap. No, everything is important for us. Okay, fine. So in a class 11, children, the first topic is speed. The children, when you open the textbook, you may not find the speed topic first. You may find a volume, but try to understand. Let us learn in a sequence. Please follow me. Please trust me. You do the best. Just listen to this class carefully. Maintain the notes. Try to note the important points when the class is going. I'll promise you that you do the best. Even after completion of this chapter in next video, I'll be discussing the numericals, exercise questions also. Be with our channel. Trust in our channel. You do it, and it's completely free. We are not going to charge. Children, it's like a service. We are not going to charge anything. We are not going to charge. It's a free of cost completely. But we are expecting one thing. What is that? Your attention, your concentration, your little bit hard work towards your preparation, and just do the hard work, get marks. Please make your parents happy and proud. That is what actually I want. That is a charge. That is what I am going to charge. Okay? Chalo, come on. So children, to understand this speed, let us take a small example. So let us say point P to point Q, it's for example 10 meters distance. Okay, 10 meters distance. Whereas point R to even point S also 10 meters only. 10 meters only. Let us say here one person. Let us say person name is Ram, and here is one more person, let us say Shyam. Okay, Ram, Shyam. Okay, fine. Now the person Ram. Okay, here is a Ram. To go from point P to point Q, he is taking for example, let us say 5 seconds of time. 5 seconds of time. Whereas this person Shyam takes 2 seconds to cover the same distance. Then what can you say about Shyam and Ram? Can you say who is moving faster and who is moving slow? Children, can you decide who is fast and who is slow? Come on, come on. Pause the video. Mention your answer in the comment box. Children, who is fast, who is slow here in this case? Okay, yes, definitely you can say that, sir, I think Sham is faster than Ram. Why? Because he is covering the same distance but he is taking less time. Less time. Okay, yes. So in this example, we can understand who is moving fast, who is moving slow. So to explain about this only, how fast an object is moving, how slow an object is moving, we have one physical quantity. That is what actually speed. Okay, speed. Zoom. Speed it is. Zoom. Okay, it's fast, very fast. Slow means zoom. Okay, but don't write it's like this in exam. Okay, by keeping a diagram. So I have seen some video there. Sir said zoom is a fast, zoom is a slow. So it should not be like that. Just okay, try to understand to give you to give a feeling between I may talk like that. So okay, try to understand here. So speed tells you how fast or how slow an object is moving. Children, speed gives you the information about an object, whether it is moving fast or whether it is moving slow. So if you want to calculate the speed, children, if you want to know about the speed, what you should know? You must know the distance covered, you must know the time also. Yes. So speed can be expressed in terms of distance and time. Distance and time. So we can write speed is equal to distance by time. Hey, I got distance by time. Children, this is a very important formula to calculate the speed. By using this formula, can we calculate the speed of the Ram? Yes, sir, we can calculate. Come on, how? Distance how much? 10 meters. Time 5 seconds. So 5 ones are 5 twos are. So here is a 2 meter per second. How about Sham here? Okay, zing zing zing. Yeah. So now Sham, distance covered is 10 meters. Speed is a 2 seconds. So this will be 2 ones are 2 fives are. So it is a 5 meter per second. Yes. So Sham is a faster than Ram, because Sham is moving with a 5 meter per second speed, whereas Ram is moving with a 2 meter per second. Okay, so here speed tells you how fast or how slow an object is moving. Okay, but how to define the speed, dear children? Yes, distance per time, right? Means the distance covered by an object in a unit time. In 1 second, dear children, whatever the distance is covered only, we can call it or we can speed. Children, make a note of it. It's very, very important. The distance covered by an object in a unit time is called speed. Okay, fine. So let us see it's a SI units. It's a SI units are meter per second, because distance is measured in meters, time is measured in seconds. Whereas in CGS units, it is measured in centimeter per second. Fine, children. But if you want to measure the speed of a bus, speed of a train, generally this meter per second, centimeter per second will become very, very, very small. You cannot. There will be a little bit bigger units, right? Yes. So to measure the speed of the vehicle, in general, we use a kilometer per hour. Kilometer per hour also. Kilometer per hour also we use to express the speed. Can I erase this? 3, 2, 1, go. Yeah. So as we are using kilometer per hour also as a unit for speed, children. So you must know the relation between kilometer per hour to the meter per second. Why? Because in exam they will ask you to do the conversions from meters per second to kilometer per hour, or kilometer per hour to meter per second. Okay, fine. Let us try to understand. Before that, children, so we know that 1 kilometer is equal to how many meters? 1000 meters. Great. 1 hour is equal to 3600 seconds. You may get one out. Sir, how come those many seconds? Yes, 1 hour is equal to how many minutes? 60 minutes. 1 minute is equal to 60 seconds. 60 into 60, 3600. Okay. Yes, sir. You're right, sir. Yes, come on. So 1 hour is equal to 3600 seconds. Now, children, 1 kilometer per hour. Can I write like this? In the place of kilometer, I will substitute 1000 meters. Okay, okay sir. In the place of 1 hour, can I write 3600? Yes, 3600 seconds. We can write sir. 0, 0 cancel. 0, 0 cancel. Okay, now 2 5s are 2 18s are. The children, 1 kilometer per hour is equal to 5 by 18 meter per second. I mean, if you want to convert the speed from kilometer per hour to meter per second, you must substitute in the place of kilometer per hour 5 by 18. Not understanding? I'll give an example. Chill, one example I'll give you. For example, speed of an object is given some 54 kilometer per hour. Now they will ask you to express this 54 kilometer per hour in a meter per second. Children, come on, pause the video. Can you convert? Can you convert? Are you able to do the conversion from kilometer per hour to meter per second? Children, clue is given on the board. Come on. Okay, done? Comment your answer. Yes, look at here. So 54. Children, in the place of kilometer per hour, we must substitute this one. So 5 by 18 meter per second. 18 ones are 18 threes are. Okay, 3 into 5 15. So it is 15 meter per second. That's it, over. So 54 kilometer per hour is equal to 15 meter per second. Then you make it a one doubt. Sir, then how to do the conversion from meter per second to kilometer per hour? Very simple, children. 1 kilometer per hour is equal to 5 by 18 meter per second. Then 1 meter per second is equal to 18 by 5. It will become reciprocal. Kilometer per hour. Now, whenever they will ask you to do the conversions. Now, let us take example for this also. Example, children. They gave you 50 meter per second. They will give you speed of an object is 50 meter per second. They will ask you to convert into kilometer per hour. Then how? In the place of meter per second, please write 18 by 5. Come on, let us do it. 50 into 18 by 5. 18 by 5 kilometer per hour. 5 ones are 5 tens are 10 into 18 180 kilometer per hour. 180 kilometer per hour. That's it. So children, this is all about speed, children. This is all about the speed. Am I clear? Dear children, if I miss anything, sometimes I also might miss, you please can text me in the comment box so that I'll try to rectify. And if you have any doubts also, please immediately just type in a comment box. I will clarify your doubts within 24 hours. If not 48 hours, if not next 24 hours. Hey, come on, but I do it. Okay, chalo. Can I raise 3, 2, 1 copied? Yay, yes. Now children, we discuss about the area. Area, not your area, my area. When you say area, where do you stay? In which area do you stay? In which area do I stay? Hey, we are staying in India, common area for all of us. Okay, fine. So now let us discuss about the area. Children, area is a two-dimensional concept. Means we discuss for a 2D bodies. Volume we discuss for a 3-dimensional bodies. Okay, now children, even in class 6th you had studied about the matter. So we know that matter occupies some surface, right? Yes, dear children. So area means what, dear children? The what we can say, the surface occupied an object. If you can take any object, if you place on the any other object or an earth also, it occupies some surface. That surface occupied only. The surface occupied by an object is called area. Okay, fine, dear children. And it is a derived quantity. It's a SI units. Usually we express in a meter square. CGS units means we express in terms of centimeter square. And here we will discuss about the area of some regular bodies, area of some irregular bodies. So how to calculate the area of regular bodies, dear children? So first we discuss area of regular bodies. So first, dear children, we discuss about the square. So square. So for example, here is so square. For example, each side is same, right? Each side. Let us say this side is some A. This all sides equal only. So for a square, how to calculate the area, dear children? So area of the square is side into side, side into side, 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 please, local boys. Okay, so side into side, not that side. Okay, now, so this side you should multiply with this side actually, or else this side with this side. Any two sides you can multiply. So that is a into a. So this is going to be a square. A square. If it is in a centimeter, a square centimeter square. If it is in a meter, it will be a square meter square. Okay, fine. Now second one, rectangle. 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 So rectangle will be two opposite sides are equal. These two equal. These two. We can say this is length, this is a breadth. So for this rectangle, the area is length into breadth we should do. Length into breadth, that's it. Okay, fine. So third one, we are going to take a circle. For example, dear children, let us draw a circle. Okay. Dear children, for a circle, some radius will be there. Let us say R is a radius. R is a radius. Then what is the area of this circle? So for a circle area, pi r square. And here pi value is given as 22 by 7 or 3.14. 3.14. Okay, na? So pi value can be given. Next, fourth one. So here is with this square surface, square area, rectangle area, circle area. So now take a cylinder. Cylinder area. Cylinder. Let us take a cylinder. Okay. Cylinder of length L. And this, let us say, is the axis. Okay, na? So this is a radius of the cylinder. R is the radius of the cylinder, L is a length. Then its area is going to be 2 pi r L. Again, pi value you can take as a 22 by 7. Okay, na? Which is approximately equal to 3.14. 3.14, right. So then the fifth one, let us take a sphere. Children, there is some difference between the circle and the sphere. Sphere means you can imagine, it's like a ball. Okay, this surface area of the sphere we are talking. So let us say here is a sphere. Okay, now the three-dimensional one. Okay, now so this sphere also has some radius, right? Yes. So its a surface area. Its surface area given by 4 pi r cube. 4 pi r cube. 4 pi r cube is the surface of the sphere. Then how to calculate? Let me tell you one example. I'll tell you. For example, area of the circle. For example, this radius is given as 2 meters. Let us say. Okay, not 2 meters. Let us say 7 meters. That much big circle. Okay. So they will ask you to calculate the example. I'm telling you. What we can say, area of the circle of radius 7 meters. Then use this formula. How? So try to understand. Pi value is 22 by 7. R square means 7 square, that is 7 into 7. 7 cancel. 22 into 7 is how much? 154 meters square. This is one example to understand how to calculate the area. Anything you can take, anything. For example, this will be given, this side is a 2 meter, this side is a 2 meter. Area of the square will be 2 into 2, 4 meters square. Okay, for example, here this side is given 4 meters, this will be given a 2 meters. Then what is the area of this rectangle? 4 into 2, 8 meters square. So wherever pi is there you can substitute 22 by 7 or you can substitute even 3.14 also to get it. So this is how actually we can calculate the area of the area of the regular bodies. Okay, can I erase? 3, 2, 1, go. Okay. Now, how can we calculate the area of the irregular bodies? For example, one of the best example, even it is given in the textbook also, for irregular bodies. Irregular bodies. Irregular bodies. The best example is a leaf. So how to calculate the area of the leaf, children? For this we are going to use a graphical method. The simple thing, even if possible, I'll try to show that even on our screen also. But before that, let me give you idea. So let us take a graph paper. Children, you know the graph paper? Graph paper, okay. So in a graph paper, like this, blocks will be there, right? blocks will be there, all blocks. Okay, now block. Blockbuster. Okay, our exam should be blockbuster. Okay, fine. Okay, now look at here. So this is like this, squares will be there. The area of each square is 1 centimeter square. I mean, one side is 1 centimeter like this. So it is a graph paper, okay, fine. Graph paper. Now what you should do? Place one leaf. Children, place one leaf. Okay, let us see, leaf, right? You please place a leaf on this graph paper. Try to trace out its edges. So that what kind of shape you get? Do we get some tiger ka shape? Lion ka shape? No, leaf ka shape milta. Okay, so you make it like this. Something like this. Oh, I am not good at drawing. Please excuse me. Yeah, like this. Okay, then what we should do, sir? Yes, first try to find out, complete squares. Complete squares. Okay, complete square, complete square, complete squares. Almost complete square. Complete square. Hey, so many we are getting. Oh my God. Okay, so how many are there? Complete squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh my God. So we got 21. So 21 complete squares. 21 complete squares. Okay, now you just count the number of incompleted square. Incomplete means what? Half or little bit more than half. If little bit smaller one is there, you should neglect. For suppose this one is there, you can neglect. Okay, so now look at here. 1, 2, 3, 4, 5, 6, 7. So less than half you don't count. 1, 2, 3, 4, 5, 6, 7. Okay, so incomplete squares are how many are there? 1, 2, 3, 4, 5, 6, 7 are there. So complete square you multiply with the 1 centimeter square. Okay, then how much you'll get? 21 centimeter square. So each block is a centimeter square. This is a this side is a centimeter, this side also centimeter. And incomplete squares you multiply with the 0.5. 0.5. So you will get a 3.5 centimeter square. Now you can add these two. 24.5 centimeter square. That's it. This is how we can calculate the area of the irregular bodies. Is my point clear? Point clear? Okay. Come on. Take this. Okay, done. So this is all about the area. Done, dear children? 3, 2, 1, go. Okay. Now, as I said, area is a two-dimensional concept. Now let us discuss about the volume. Let us make some volume. Well, volume. Oh, it's not related to sound. That volume is different. This volume is different. Okay. Yes. So volume is what, children? Yes. So if you can keep any body, now you can imagine a three-dimensional body. If you can take any body, dear children, see, for suppose if you can take, here is a body. If you take this body, it occupies some, here surface, some length it will take, some breadth it will take. Length, breadth, height, three are involved for any three-dimensional body. Okay, so every object occupies some space. That space only we can call it as a volume. So surface occupied is called area. The space occupied by an object is called volume. Am I clear? Okay. So space occupied by any object is called volume. So its SI units are actually meter cubes, and here we also can express in terms of centimeter cube. So volume is expressed in terms of meter cube, in terms of centimeter cube also. But whenever we are measuring the liquids, dear children, we also use milliliter, we also use liter. Yeah, actually I noticed that many students are getting a confusion. They're getting confused to do the conversion for a centimeter cube to milliliter, liters, to all these things are there. Hey, we'll make it very simple. Dear children, first what I mean is that let us take one cube. Cube means what? all sides must be same. Length, breadth, height. Shall we construct like that? Yes, we can. Children, look at here. Here, let us try to construct one cube. Cube means you all know that all sides must be equal. All sides must be equal. Of course, I am trying my level best. Okay, so this is a three-dimensional concept. Children, now this each side is, let us say, centimeter. Here is 1 centimeter. Height is 1 centimeter. This length also 1 centimeter. Length, breadth, height 1 centimeter, 1 centimeter, 1 centimeter. Now for this, what is the volume? Volume of this one is a 1 centimeter into 1 centimeter into 1 centimeter. 1 centimeter into 1 centimeter into 1 centimeter. So this can be written as 1 centimeter cube. Okay. Now dear children, so we have, okay, here I don't have anything to show. Something like that. Let me try. Oh sorry. Yeah. Children, let us think it is a cube. Sir, it's a cuboid. Children, I know that. Please excuse me. Just assume that it is a cube. Height is 1 centimeter. Width is 1 centimeter. Length also. Assume. So now look at here. So complete. Top is open. Let us say it's a 1 centimeter cube volume. In this, can I pour some water? Yes, we can pour. How much amount of water can fit in this, in this I mean to say. If you want to pour in this also, if you want to fill this, if you want to fill completely, try to understand. If you want to fill completely this, how much of amount of water it can accept, 1 milliliter. 1 milliliter. That is 1 ml. So 1 ml means 1 milliliter of liquid only can occupy 1 centimeter cube volume. So if you can imagine a cube of volume 1 centimeter cube, in that how much amount of liquid can be taken, only 1 ml. So 1 milliliter of liquid can fit in this 1 centimeter cube, which means what, dear children? 1 centimeter cube equal to 1 milliliter. Very much important relation. 1 centimeter cube is equal to 1 milliliter. How to understand? This is the best way to understand. 1 centimeter cube is equal to 1 milliliter. Okay, fine. And let me also tell the conversions of meter cube to centimeter cube. Please let me tell you here. Children, we know that 1 meter is equal to 100 centimeters. This can be written as 10 square centimeter. Whereas 1 meter square is equal to, square this side also. It means 10 square centimeter whole square. This is going to be 10 power 4 centimeter square. 1 meter cube is equal to, children, try to understand, 10 square centimeter cube. This will become 3 into 2, 6 centimeter cube. So 1 meter cube is equal to 10 power 6 centimeter cube. Very important. Very much important. Or else 1 centimeter cube is equal to, bring this, see, 1 centimeter cube is equal to, bring this 10 power 6, it will go to denominator, 1 by 10 power 6 meter cube. Whenever you can bring this denominators to numerator, the power will become negative. So 1 centimeter cube is equal to 10 power minus 6 meter cube. Children, these units are very important to do the conversions and to do the numericals. So 1 meter cube is equal to 10 power 6 centimeter cube, or 1 centimeter cube is equal to 10 power minus 6 meter cube. And this is very important. 1 centimeter cube is equal to 1 milliliter. 1 centimeter cube is equal to 1 milliliter. Is the point clear? So this is what actually the concept of volume, its units and a conversion. Okay, fine. Now volume of regular bodies, volume of irregular bodies we discuss. Can I erase? 3, 2, 1. Okay, fine. Rana Bombay ki Rana, Rana Bombay ki Rana, Tana Tana. Yes, fine. Yes, okay. Now I said that volume of regular bodies we are discussing. volume of what is children? Regular bodies. Volume of regular bodies. Volume of regular bodies. In this first one, cube children. Very simple. Cube means all sides must be equal. Just now we discussed, right? Cube, each side must be same. A. So for cube, volume can be side into side. So just multiply the three sides, you will get answer either in terms of cubic centimeter or cubic meter, you get the answer. Okay, fine. And the second one, cuboid. So it seems to be like this. Okay, let me try my level best to make it to give you three dimensions. So length, breadth, height will be different. Length, breadth, height. So for this volume, how can you calculate? Length into breadth into height. Again, you will get answer in terms of cubic meter or cubic centimeter. Okay, so it is a cube. Okay, and here is a cubic meter. Next, let us take a sphere, children. Sphere. So let us take, for example, sphere, three-dimensional sphere, like a ball you can imagine. It has some radius. So for this, how to calculate sphere volume will be 4 by 3 pi r cube. Children, as I told you that again, r value will be given. Okay, you substitute here. Pi is equal to, you can take a 22 by 7, that is 3.14. Okay, fine. So this is a what we can say volume of the sphere. Next, cylinder. So you need to practice, children. Just remember for these classes. In higher classes in maths, I think you will learn how these things we got and derived everything. Of course, I think even maths also, I don't think so derivations are important, but with the derivations you will understand. Okay, so cylinder, if you can take, let us take, here is a cylinder. Let us take cylinder of height h. Okay, and here is its axis, and this will be the radius. So now its volume will be pi r square h. So pi r square h is a volume of the cylinder. Okay, fine. And the fifth one, let us take a cone. Hey, cone kya hai? Hey, during the birthday, some small children will just wear that, it's birthday cap type, or it's a mehendi cone, same structure. Okay, so this will be like this. So you can take, here is a cone, dear children. So this cone also has some height. Let us say its height is h, and it has some radius. Okay, now let us say the radius is r. Okay, so then the formula to calculate the volume of the cone is, it is a pi by 3 r square h. So don't get confused. Just have some practice, you will get it. Practice makes students perfect. Is the point clear? Okay, na? I think when I am teaching, some of you may think, sir, physics is the most subject which I hate, which I get irritated. Of course, it might be true, but I am helpless. Yes, try to understand, try to follow the concepts. Okay, children. Okay, get back to the topic. So this is how actually we can calculate the volume of regular bodies. Children, and before going to learn about the volume of irregular bodies, here we should understand how can we measure the volume of a liquid, children. So to measure the volume of a liquid, actually we have two special devices we have. Here, do we have that? Now, dear children, let us try to understand how to measure the volume of a liquid, children. So to measure the volume of liquids, we have two vessels actually. One is measuring cylinder, another is measuring beaker. So first one is we have measuring cylinder, and a second one measuring beaker. So let us try to understand. Let me show you the children. So here is measuring cylinder. Can you see this? Can you see? Let me try to bring to you. I don't know whether you are able to see it or not. So here is actually, it might be made up of with glass or plastic, so preferably plastic. Okay, fine. And here just you can see, so it is 10, 30, 50, I think up to 250, means what? 250 ml. 250 ml. Children, can you please tell 250 ml is equal to how many centimeter cubes? Come on, pause the video and comment your answer. 250 ml is equal to how many centimeter cube? I'm asking you to do the conversions from milliliter to centimeter cube. Okay, got? 1, 2, 3. Got the answer? Yes. It is 250 centimeter cube. Kaiku, because 1 milliliter is equal to 1 centimeter cube. 1 milliliter is equal to 1 centimeter cube. So children, so this is actually what we can say measuring cylinder with which we can measure the volume of liquid. But here, for example, you can take unknown amount of water or any liquid, you can pour into this. So by measuring this, you can calculate. Okay, na? Is the point clear? Yes. And this is a very important, what we can say, vessel which we use to measure the, which is used to measure the, density of irregular bodies. Children, if possible, after completing these chapters, practical also I will show you in our channel how to find the density of irregular body. Practically, children, be with our channel. I am going to upload even the practicals also. Okay, fine. And one more thing is what actually measuring beaker. I think if I am not wrong, it is given, but on this measuring 500 ml is there. So measuring a beaker, the difference is that with the help of measuring beaker, you can measure only fixed volume of liquid. Fixed volume of liquid. So if possible, I will try to show some what we can say measuring beakers on our screen, and you also can see the measuring cylinders. So these measuring cylinder, pharmacists also can use that shape. Also, I'll try to show you. Two kinds of measuring cylinders will be there. And a measuring beaker. Children, have you seen any time? So see, nowadays we all are purchasing the milk packets, but still in some apartments, in houses, the person is bringing the milk. So how they are measuring? Did you notice any time? Just ask your parents, ask your mom how they are getting the milk. If not packets, how they are getting? The person will come. Yes, they have a measuring, that is a measuring beaker. It might be 250 ml, 500 ml or 1 liter. So with the help of measuring beaker, we can measure only fixed amount, fixed volume of liquid. Try to understand. If you feel that, it will be, for example, 250 ml is written, 250 ml volume. 500 ml is written, 500 ml of volume. 1 liter is written, 1 liter volume. That's it. So with the help of a measuring beaker, we can take the fixed volume of the liquid. Okay, fine. So children, so here these are the measuring cylinder, and as I told you, so it is a measuring cylinder, right? Okay. Now the thing is that, so why it is important for us now? Of course, if you want to calculate the volume of irregular body, measuring cylinder is important. How? Let me tell you here. So for suppose, children, here is a measuring cylinder. So rough diagram I am making. Hey, please try to understand. I may not be good at the diagram. Okay, you have to bear. Do you have a chance? No. Why not? You can just pause the video. You can switch off the video. You have a chance. But it's again I'm telling you, it's not a matter whether you like me or not, or whether you like your teacher who is teaching you or not. You must like the subject, the children. Person is not important for you who is teaching. Subject is important. That's very important. Okay, it is your life, your career. Don't go to any personal things. Sometimes teachers may raise voice. Doesn't mean that they're targeting you. Don't think that they want to corner you. It's not that. They're not pointing out you. It means they have some concern, special attention towards you. I think they are thinking by being the place of your parents. They're like, that's what we can say, teachers are like a second parents. Don't forget that you are spending more time with your teachers. So where they may raise voice, they may shout just to correct you only. Keep that in your mind. Doesn't mean that to insult you or something. Don't take anything to your heart. Think with your brain. because when heart involves, you'll completely become emotional. No, let your brain dominate. Then you will think what is right. If sir raised voice, the teacher raised voice, why? Something is going wrong. Set that over. It's for you, it's for your life, it's for your career, not for teachers. They'll come, they'll teach, they'll go happily. But try to understand, a good teacher, they want to teach and even they want to correct the student also. If you are doing some indisciplined things, the good teacher always will correct. They don't think, let it be why I want. No, we want everything. Your discipline, your knowledge, your studies, everything. We are here to take care about you all day, children. Please keep that in mind and just be positive towards your teachers, their teaching and everything. If anything is not clear, yes, you have full rights to ask. Come on, raise your doubts. No teacher will say no to doubts, ma. Any doubts you can ask the teachers. Children, you can go to the school with doubts, but you cannot come back to the home with the same doubts. Then that day is useless. Okay, so any doubts you can ask teacher. Yes, all teachers are ready to explain. In fact, we are very happy when our children are asking the doubts. You don't know that. We'll enjoy the doubts. Okay, fine, get back. So this is let us say it's some measuring cylinder. Just a rough random arbitrary values I'm taking. Let us say this is 5, it is 10. From here it is starting 15, let us say it is 20, 25, 30, 35, 40, 45, 50, 55, some 60, 65, some 70, 75, 80. Let us say its capacity is 80 ml. 80 ml, children. So initially I have taken water till here. So this is, so please this you note down first. See here exactly 20, but when you take a bigger, it might be 20.1, 20.2, 20. Like that also. To give a more clarity, to make it simple, just have taken this. So this is called initial volume. So note down that initial volume of the liquid. So initial volume, that will be V1. Please note down, this is going to be 20 ml. 20 ml. Now for example, here one stone you have. Stone, you want to find the volume of the stone. It is irregular body. Then take that stone, just completely immerse in it. Okay, now. So let us say, yes, that stone is immersed completely in this. Then do you think that water will stay here? No. Some water will be raised, some water will be displaced. Let us say water has reached till here. Till here water has reached. So read this. This one. This will be this is initial volume. This will be the final volume. Whatever you get that level, till that you can read it. That is actually final volume. Final, I mean volume of the liquid. Initial, this is final. Let us say 30 ml you got. 30 ml. Now how much amount of water is displaced? So volume of displaced liquid. Volume of displaced liquid. How to get it? Final volume minus initial volume. This is 30 minus 20. This is 10 ml. The children, the volume of the displaced liquid is equal to the volume of the solid submerged. Volume of the solid submerged. Now what is the volume of this solid, children? Yes, so now that solid volume is 10 ml. Then you may get a doubt. Sir, ml is a unit which we use to measure the volume of liquid. But how can you write for a solid? Hey, don't forget that. 1 ml is equal to 1 centimeter cube. Now by using this I can write 10 centimeter cube. Hey, now tell me what's your problem, man? Come on. Do you have any problem? No sir, we don't have any problem. Yes, come on. So this is called actually displacement method. This is called displacement method. Displacement method. So this is how actually we can measure the volume of the, this is how we can measure the volume of the irregular body. Children, please remember this method, because this method is very important to calculate the density of irregular bodies again. Same procedure, displacement method. There also, again I don't explain. I'll tell that we discussed previously, I'll tell. So you should recall. If possible, this screenshot again I will place there. Okay, na? So this is the concept of volume, volume units, conversions of units, and how to calculate the volume of regular bodies and irregular bodies. Okay, fine. Now we discuss the last concept. Hey, when I say last concept, some students will think, thank God, sir, chapter is going to be finished. Children, it might be a 1 hour or 1.5 hour video if I am not wrong. So, see, I am trying to cover each and every point. Of course, being a teacher, being an experienced teacher, we can explain the entire chapter even in 20 minutes also. So, our intention is just not to complete. So, just you should understand. Okay, fine. Let us discuss about the density. Let us discuss about the density. Yes, fine, children. Children, let us think about any substance, matter. So we know that every object has some mass. Yes or no? Yes. Without mass, do there some object can exist? No. Every object has some mass, and every object occupies some space called volume. Try to understand. So these two are the two important properties of a matter. Two important properties of matter. Every matter has some mass, and every matter, every object, that I can say that mass also occupies some space called volume. Any object you can take, it must have some mass, it must have some volume. It must have some volume. So children, let us take some example to understand what actual density is. As per the textbook, let us take that. So children, let me give you an example. So you might be doing cotton, yes, iron also. Children, let us take a 1 kg iron, okay, 1 kg iron, and 1 kg cotton you can take, 1 kg cotton. So 1 kg cotton, 1 kg cotton. So what makes the difference? Children, both mass is same, but if you can see the space occupied, here is less occupation, more occupation. What I mean to say that, so mass might be same, but volume is different. Which occupies less volume, dear children? Iron will occupy less volume, cotton occupies more volume. Why like that? Means in iron, the molecules are very close to each other. You can take even small quantity of iron also. In that, iron molecules are occupied, they are arrested very closely. The intermolecular space is very less in this than this cotton. Okay, fine. Let us take one more example. Now let us take a same volume of what I mean to say that iron and a cotton. So for example, let us take a same volume I have taken. Same volume, okay. So let us take a same volume, let us some 1 meter cube I have taken volume. Even 1 meter cube cotton I have taken. Please try to understand. Iron, cotton, same quantity. The children, now you tell which one will be more heavier. Same quantity we have taken, same volume. Obviously you can say that yes, iron is more heavier than cotton. So whenever I give you examples like this, iron, cotton, these kind of examples, definitely one term will come to our mind called heaviness. Means how compact an object is. This property, this physical, what we can say quantity, which describes how compact an object is, only we can call it as a density. To express the density means density, we should know the mass and we should know the volume. So density can be described in terms of mass and volume. Now simply density is equal to mass per volume, mass by volume. So how can I define the density, children? Mass per unit volume. Just you take the unit volume of any material, it has some mass. You divide its mass with its own volume. Any object you can take, every object has some mass, it occupies some space. You divide its mass with volume, then what you will get? You will get a density. You will get density. Is the point clear? So how can you say denser, lower denser? Let me give you concept. For example, you take a water, try to throw a stone, it will sink. Why? More denser than water. But you take a thermocol ball, throw in a water, it will float. Why? Its thermocol density is less than the density of the water. Okay, fine. Let us just try to discuss some more concepts related to this. So children, so what is the density, ma'am? So the mass per unit volume, is called density. Means denser means what actually? In that object is more compact. In a less space, more atoms are there, means we can say more density. That's a very simple, as simple as that. Okay, so here density is equal to, simply we can write as a mass per volume. So mass per unit volume is called density. Children, SI units. In SI system, mass is measured in kg, volume is measured in meter cube. Okay, so by using this, just you substitute the mass units, volume units, you will get the density of units, that is kg per meter cube. That's it. Next, CGS units. In a CGS system, mass is measured in grams, volume is measured in centimeter cube. Now you substitute mass units, volume units, you will get gram per centimeter cube. Children, let us recall the conversions already we discussed. 1 kg is 1000 grams, can be written as 10 power 3 grams. Already we discussed at the beginning only. 1 meter cube is equal to 10 power 6 centimeter cube. These are very important. Why? For the conversions. Look at here. 1 kg per meter cube is equal to how many grams per centimeter cube? Very simple. In the place of kg, you substitute 10 power 3 grams. 10 power 3 grams. Okay. In the place of meter cube, 10 power 6 centimeter cube. Now, how to do the simplification? Yes, look at here. Bring this 10 power 6 to the numerator, it will become 10 power minus 6. So, 10 power minus 6. Already 10 power 3 is there in a numerator. Grams per centimeter cube. Children, whenever bases are same, power should be added. Minus 6 plus 3. This is going to be a minus 3. Simple maths it is. So, 1 kg per meter cube is equal to 10 power minus 3 grams per centimeter cube. Children, 10 power minus 3 means if you can take the denominator, it will become 10 power 3 only. So, this can be written as 1 by 10 power 3 grams per centimeter cube or 1 by 1000 grams per centimeter cube. So, this is 1 kg per meter cube is equal to 1 by 1000 gram per centimeter cube. Or you bring this 1000 this side, it is multiplied, right? So 1 gram per centimeter cube is equal to 1000 kg per meter cube. Very important. Very much important. Okay, na? Please copy this. Then we will proceed how to calculate the density of regular bodies, density of irregular bodies. Please copy this. Now children, let us see how can we calculate the density of regular bodies. Density of regular bodies. Density of regular bodies. Very simple. Regular. For example, let us say one cube is given. If anything cube, cuboid also anything. Cube it is. Okay na? So cube. Okay na? Cube is given. First, by using electronic balance, let us calculate its mass. We can calculate. Let us say we got its mass as example. I am telling, not exactly. Okay na? So it might be, for example, 1250 grams is there. Example on exactly. I don't exactly. So we have taken one block cube. It's a cube. Okay, and we have to measure its mass with the help of electronic balance. So we got it as a 1250 grams. Now, so let us say this cube of side 5 centimeter, 5 centimeter, 5 centimeter, 5 centimeter, 5 centimeter. If not, also you can use a scale. If it is a cuboid also, you can use a scale to measure length, breadth, height. Why? To calculate its volume. So volume, if you want to calculate, these 3 sides we should measure. 3 sides you must measure. Okay, let us see this. This is a 2 centimeter. This is 4 centimeter, something like that. Okay, and wait. So let us, this we got 100 grams, example I am telling you. Okay, now length into breadth into height. So length is 5 centimeter, breadth is 2, height is 4. So this is 40 centimeter cube, 40 centimeter cube. Now what is the density? Yes, so here density is equal to mass per volume. So mass is how much? 100 grams. Mass is how much? 100 grams. Volume is 40 centimeter cube. 0, 0 cancel. 10 by 4 is how much? 2.5. So 2.5 grams per centimeter cube. So if you want to convert into kg per meter cube, you must multiply with 1000 children, because we know that 1 gram per centimeter cube is equal to 1000 kg per meter cube. You substitute on that. So then density is equal to 2.5 into, in the place of gram per centimeter cube, you must write this, that is 1000 kg per meter cube. Now 2.5 into 1000 is how much? 2500 kg per meter cube. Children, 2500 kg meter cube, 2.5 gram per centimeter cube. Mathematically both are equal. Don't think that so 2500 is more, of course 2500 is more only, that number is more, but see the units also. So this is how actually we can calculate the density of the regular bodies. Any body, sphere, anything, calculating mass, calculating its volume, because we know the formulas to calculate the volume of the regular bodies. We use that concept. Now, how to calculate the density of irregular bodies? Irregular bodies. Hey, I said now, when I was talking about the volume of irregular body, stone, I said that it is going to be useful. Yes, recall that, stone. Did you remember the stone, dear children? Okay, so first here one stone is given. How to find out its density? First the thing, we should measure the mass. How to measure the mass of the stone, children? By using the electronic balance. Let us say that its mass we got some 55 gram, let us say. This is a mass. And how to find out its volume? How to find out its volume? By using a displacement method. By using a displacement method. Sir, what is this displacement method? Just to go back to the video backward. When I was talking about the volume, there only I said this is very, very important, which we use to calculate the density of irregular body. If possible, I'll try to just place that photo on the screen also. You can look into that. So that is how we can calculate the volume of a irregular body. So in this video only we discussed about this example value, how much we got. We got it as a 10 centimeter cube. So now density of this stone. Density of this stone is its mass 55 grams by its volume. 55 by 10, it will be 5.5 gram per centimeter cube. Gram per centimeter cube. That's it. Children, here I declare or I conclude or I can say that chapter is over. Okay, I think you'll be happy. So children, try to understand. So with these concepts, I think as per my knowledge, I covered almost all concepts. I might have missed a few here and there examples might be. So that's what I advise all students. You must read the textbook, not these videos and material. It's not that. First read the textbook. It's very important. First read the textbook, then come back to the video. If you need, I'm not asking you to. Children, if your teachers are good at, yes, you go to them, it's very, of course, all physics teachers are wonderful, I know that. All teachers will do their best, but thing is that how you listen to the class is very important. Please understand, children. So whenever we think about physics only, even parents also, sir, physics somewhat subject, nothing, their parents and children. Physics is the after all subject, like other subjects only. Don't give some special attention or special place for physics. So let your children, dear parents, I'm talking to you only. Please let your children start the physics subject with a positive attitude, not the negative attitude. If you say that physics is a tough subject, focus more, read more. No. Don't say that. Just say that, children, physics is easy, physics is a fun, physics is a enjoy, physics is a happy. See that their attitude will change toward the physics subject. It's my humble request. Please, dear children, this is very, very, children and parents, very, very important, very, very, very important. Okay, so as I told you that once this video is uploaded and within 1 or 2 days, I'll try to discuss the numericals related to the chapter 1. Once those numericals video is uploaded, then I discuss even chapter 2 also. And here now today I make one promise that yes, I will upload all chapters of 7th class, not only 7th, 6th, 7th, 8th. Actually in our channel already we discussed 9th, 10th. 9th, 10th complete syllabus we uploaded in our channel only. Now we start uploading 6th, 7th, 8th, because few parents, I am not saying all, few parents who will personally like me, I can say that, and they are they are requesting me to make a video so that it's very helpful for their children to revise for the exams. It's very important. Children all may not like us, at least few are there. So for those few parents, for those few students, we are making a videos, we are uploading. Okay, na? So hope this video is very helpful to you for your exams. Revision might be unit tests or might be term 1, term 2 or annual. I don't know when you are watching also, because I don't know whether you're watching tomorrow or after 1 month or after 1 year. I don't know who is watching also. Okay, children, only so my wish is that yes, do the good. Children, I want one thing from your end. I told you, it's a one Guru Dakshina type. Hey, don't get contents. I'm not going to ask money. I'm thinking, no, we don't want any money. As I told you, that's a free service. It's a free service. Okay, purely free. But thing is that please prepare well, get the good marks, and just make your parents happy. And don't forget to subscribe our channel, and please suggest our channel to your friends and ask them to subscribe. So that is a great thing which you can do to our channel. Thank you so much. All the very, very, very best.